Hello, today we are going to see the chapter Scalars and Vectors. Now, what are scalars and what are vectors and what are scalars and vectors? We know that in this world there are many physical quantities. Now, what are physical quantities? You see, physical quantities are those properties of the all the materials and things around us which are related to physics, or they are the outer properties of the material. For example, the mass of a object, or its speed, or its velocity, or its acceleration, or a force that is exerted on it, or its temperature. All these things are physical quantities, and these physical quantities can be measured. Now, what is the difference between these two type of physical quantities called as scalars and vectors? You see, scalars are those physical quantities which are having only magnitude, means only a number is associated with them. But vectors are those physical quantities which are having a magnitude as well as a direction. Now, what is this direction? Now, you see, if we are applying a force, it is not that it is just what is the amount of force you are applying, but in which direction you are applying the force. A force which is downward is different from a force which is upward. That is why these two forces, when we when we either do the algebra of these vectors, then at that time we will see that they cannot. The algebra of vectors is not like the algebra of scalars. Scalars we can add and subtract just like numbers, but vectors we cannot do that. So that distinguishes scalars from vectors. Now let us see here, as you can see, some examples of scalars and vectors. Mass, volume and temperature. Mass, volume and temperature are examples of scalar quantities. And force, velocity and acceleration. Force, velocity and acceleration are examples of vector quantities. So you see, these quantities are associated with a particular direction. So that is why they are called as vectors. Now, vector algebra, or addition, subtraction, multiplication and division of vectors, is not quite similar to scalar algebra. You can add, multiply, subtract or divide scalars just like any numbers. But in case of vectors, you cannot do like that. So just let us see how vectors are having their algebra different from the scalars. You just see 10 plus 10 is equal to 20 if both of them are scalars. But 10 as a vector plus 10 as a vector is not, we cannot say, we do not know what is the magnitude of this resultant. So for this we have to apply some different laws or different properties of different calculation methods for calculating the resultant of, or the output of this summation, which is one vector plus another vector. You just see there are two laws of vector addition. They are called as triangle law of addition and parallelogram law of addition. Now, what is a triangle law of addition? Let us just see here. Triangle law of addition. You see, if two vectors A and B, they can be, if vectors A and B can be represented by two sides of a triangle, then the third side, starting from this point to this point, this arc will be the third side, will be the resultant of the addition of these two vectors A and B. You see, here I have written A plus B is equal to R. R is the resultant and it is the summation of A and B. So A plus B is A plus B is equal to R. This is the third side of the triangle. This is one side of the triangle. This is beginning point here, ending point here. From this ending point begins vector B, which ends here. If we connect the beginning point of A to the ending point of B, we will get the resultant of A and B. This is called as the triangle law of vector addition. Now let us see. I will remove this and show you what is the parallelogram law of vector addition. You see, the parallelogram law of vector addition is just like this. If this is one vector, this is another vector, you see, if two sides of a parallelogram which are touching each other, originating from a particular point, represent two vectors, then the diagonal of the parallelogram is the resultant of these two vectors, resultant or the summation or addition of these two vectors. You see, here also we can write that a plus b, a vector plus b vector is equal to r vector. You see, r is the diagonal. R is the diagonal of this parallelogram. A is one vector like this, b is another vector like this. A plus b is equal to the diagonal. So this is the parallelogram law of vector addition. Similarly, there are different methods by which we have got multiplication of vectors. There are two kinds of multiplication of vectors. One is the scalar product and second is the vector product, but we are not going to deal with them right now. Now we are just going to end here by this addition of two vectors, how we can add two vectors. Thank you.